So last class, we were working on unit rates and we had tables and we were exploring the tables to see what happened, how X and Y were changing. So in this table, as X increases by 8, Y we see went from 10 to 6, so it decreased by 4. So last class you guys would have written the sentence as X increases by 8, Y decreases by 4. And then you would have scaled that down into a sentence that started with as X increases by 1. So remember to do that. If we want to turn 8 into 1, we divide by 8. So we would divide 4 by 8. 8 divided by 8 is 1. 4 divided by 8 is 0.5 or 1/2. So you would have written the sentence as X increases by 1, Y decreases by 1/2 or 0.5. So our slope, because it decreases, our slope would be negative. It decreases by 0.5 or 1/2, so my slope would be negative 0.5 or negative 1/2. So today, as we find slope, we aren't going to write sentences, but we're going to use that concept because every single time, remember, our unit rate shows up in the last part of that sentence once we turn it to 1. Our unit rate shows up in the last part of the sentence. And so here, the last part of the sentence, to get that last part, it came from dividing 4 by 8. So if we think about 4 divided by 8, we could rewrite that as 4 over 8. Remember, the fraction bar means division. If we go back to that original sentence to look and see what was that 4, well, y decreased by 4. So I'm just going to add a negative sign for that decrease part. And that was how much y changed. So this negative 4 was our change in y. And as x increases by 8, so that 8 is our change in x. It's how much x changed. And that leads us to how we're going to find slope today. We're going to look at it in a few different problems. Rise over run, change in y over change in x, and delta y over delta x. So this triangle, that is the Greek symbol, delta, but it means change in. So when we say delta y, that's just the shortcut for change in y. Same thing for delta x and change in x. It's just a quicker way to write it or abbreviate it. You've already been finding slope. We're just going to officially name it today. Slope is the constant rate of change between any 2 points on the line, right? So that it's changing, but it's changing the same amount each time, a constant amount each time. That is the unit rate that we've been looking at in some of our problems. It does tell us how steep the line is. Bigger the change, the steeper the line would be. And then just a note here where it says slope equals m, m is the letter that we use to represent slope, and that is the same m that we see in this equation y equals mx plus b. So that m is our slope, our unit rate. So we have 4 kinds of slope. If the slope is positive, we on the graph would see that line going up from left to right. Like in the walkathon, the person that got $2 every kilometer, every time they walked a kilometer, we added $2 and we saw the value of their money going up. If the rate of change, if the slope is negative, we're going to see that line going down. So this would be similar to the problems with Ms. Chu's advisory and Mr. Albury's advisory, where they were spending money each week. So one of them was spending $12 each week. And so their balance was falling. Their slope would have been a negative 12. And their line was falling. For zero slope would be like the person in the walkathon that got $10 no matter what. So their money, the amount of money they were getting, wasn't changing. And so when we have zero slope, we're going to see a horizontal line like that. And then for undefined or no slope, we're going to explore this more later, we would end up seeing a vertical line. And so the tricky part to notice is that there is a difference between something having zero slope and something having no slope, which is something new, right? Because for you, historically, no and zero kind of matched up. For example, if you had no apples, you had zero apples. That is not the case here. Zero slope and no slope are two completely different things. So what you can imagine is if I were on a treadmill, I could walk on my treadmill if it was flat and my incline would be 0%. However, I could not walk on a treadmill that is set up like this. That is not possible. So on the zero slope, we can find the slope. It just happens to be the number 0. For undefined or no slope, we cannot find a value for the slope. It doesn't exist in our number system. So the next thing that we're going to do is to use what we know about slope to find the slope in a few different situations, okay? So if we're trying to find the slope from a graph, the first thing that we're going to do, often on graphs, we can think about rise over run. And rise is your vertical change. Remember, it's the change in y. So it's either how far up or down you went. If you go up, that's a positive change. If you go down, that's a negative. And then run, right? Just like if you were running side to side, we could run left to right. If we run to the right, it's positive. If we run to the left, that's negative. Just like on a number line, if you move to the right, your numbers get bigger. If you move to the left, your numbers are getting smaller. So there's that connection. So on this graph, what we want to do is draw a triangle from one point to the next. It's always going to be a right triangle. We call these slope triangles. So I'm going to start at this bottom point and I'm going to go up, and then I need to turn and go to the right to get to that second point. And so when we're finding our rise, we just said we went up, and we need to count like how many spots we went up. So 1, 2, 3. So I went up 3, so that would be a positive 3. So my rise is a positive 3. And then for my run, at this point, I would have to turn and go 2 units to the right. So because we went to the right, it would be a positive, and we went 2 units. So my run is a positive 2. And then at this point, we're just simplifying the fractions. So a positive divided by a positive is a positive. So my final answer is going to be positive. I don't need to write that plus sign in my final answer. And then can we simplify 3/2? Are there any common factors? There are no common factors. And so 3/2 is simplified. We love improper fractions, so we're going to leave it as 3/2. So for number 2, we have 2 points. We have the point -1, 4, and we have the point 2, 10. Sometimes it can be helpful to write them on top of each other. And then it's important to remember that our ordered pairs are always x, comma, y. And so now we need to find delta y over delta x. So to do that, it's very similar to that table that we were using last class. If we want to know how much x changed, then from -1 to 2, that's an increase of 3. We went up 3, so that's be a plus 3. For my y's, we went from 4 to 10. That's a plus 6. And so when we start to write our delta y over our delta x, we just need to make sure that we're being really careful. Delta y was a plus 6, so we just need to make sure that we write that in the numerator of the fraction. Delta x was that plus 3, so in the denominator, we're going to put a plus 3, and then we simplify. So a positive divided by a positive is a positive. 6 divided by 3 is 2. Final answer. So we love fractions, but if we can write it as a whole number, we would. Okay, so we have slope from a graph, we have slope from 2 points, and now we need to find the slope from a table. The good news, the slope from a table is very similar to the slope from 2 points. Again, we need to find delta y over delta x. So to do that, we're going to look at our fractions from 4 to 8. That is an increase of 4. From 8 to 14, that is an increase of 6. From 7 to -3, we dropped 10. And from 3 to -18, we dropped 15. So when I go to write my delta y over delta x, it's just important that I remember which one's delta y and which one is delta x. So for delta y over delta x, I have some possibilities. The first possibility, I could write the fraction -10 over +4. My second possibility is to write the fraction -15 over 6. And then if I reduce those, so I could, common factor of 2 on the first one, I could divide the -10 and the 4 by 2. And that would give me -5/2. And then if we look at the second one, 15 and 6, they have a common factor of 3, so I could divide them both by 3. If I do that, I still get -5/2. Remember, a line has a constant rate of change. So if it is linear, doesn't matter which fraction I choose, they're all going to lead me to the same slope. Both of these fractions led me to -5/2 for the slope. Okay, so if you're on a graph, maybe rise over run is the easiest to picture, or delta y over delta x. It doesn't matter when you're thinking about example 2 and example 3 with points, with ordered pairs, or with the table. You are finding those changes. How much did y change? How much did x change? So that you can write your fraction delta y over delta x and then simplify. So today you're going to do these 4 problems from task 1. And then you're going to choose one problem from task 2. You can enlarge this on the slideshow, but I am going to point out a few things. First of all, this says that this is the point 07. So this has a height of 7. And this says it is the point 50. So that x value is 5. So as you are drawing your slope triangle on your paper, right, you can just draw me the triangle. You don't have to show me the whole graph. Then you can label the rise and the run on your triangle and then use that to find your slope. Okay. Number 2 is like the example we just did. Number 3, I just want to point out that negative got hung on that second line. So the points are -6, -4. Don't forget that negative sign. And -2, 5. And then for number 4, the points are -1.50 and 4.5, -5. So you're going to find the slope for those 4 problems. And then on task 2, you can pick either problem. The questions are asking which slope triangles either would fit on the graph for number 1, or for number 2, which of those slope triangles could fit on the same line. So some things for you to consider, like for number 1, you would need to know the slope of the line. Notice we don't see any points plotted, so you're going to choose which points you want. So for example, I might choose that point because it was really easy. If you notice, it's in the crosshairs. We can see exactly what the x value is and exactly what the y value is. So that would be a good point to choose. I would not want to choose this point because I don't know exactly what the x value is. Could I estimate? Sure, but we don't want to guess. So once you find your other point, maybe it's this one, maybe it's this one, you're going to draw your slope triangle. Doesn't matter which one you draw, actually, and you're going to find the slope of that line. And so if we extended that line, the question is basically saying there are lots of triangles I could draw on this graph. I could draw many triangles, and we want to know which of these 3, A, B, or C, would fit. Okay, well, if they're going to fit on that line, then they would have to have the same slope on that side that I just darkened. That line would have to have the same slope as the line that's drawn, so that that triangle could just slide right on top where you see some of these other triangles. So then we would need to find the slope Again, thinking rise over run of A, B, and C. And then if any of those slopes match the original line, then that triangle could fit. So maybe they all fit, maybe none of them fit, maybe one fits, maybe two fit. You need to test them all to see. Okay. And then likewise for number 2, it says which of the following triangles could be used to find the slope of the same line. So if they're on the same line, the slope would have to be the same. So if I call this triangle 1, 2, and 3, so we're really thinking about, do any of those have the same slope? Maybe none of them do. Maybe 2 of them are the same. Maybe they're all 3 the same and they could all be on the same line. So again, we would have to find the slope. We would have to find rise over run for each of these 3 problems and then consider, are any of them the same? Now, when we start to compare the slopes, maybe on this, maybe it's easier to think about it as a decimal as you're comparing so that you could quickly see, are they equal or are they not, okay? So your job today, you're going to do task 1, you're going to do all 4 problems, and then for task 2, you're going to choose at least one problem to work. You're going to take a picture of these problems and upload it to Google Classroom. As always, reach out if you have any questions or concerns. Take care.